This is Mark Anderson for Kellogg Community College, and today we're going to look at product rule, power rule, and quotient rule for logarithms. Now we'll start off by reminding ourselves some simple rules of exponents. So what I'd like you to do is kind of go over to the left side of your margin here, and I'd like you to write down some of these older rules from the exponential unit that you may have learned. So if we have x to the a times x to the b, you would add the exponents. So this would be a plus b. So we have the product meaning addition. So analogy of this, if I have log base b of x times y, that would be the same as log base b x plus log base b y. Over here, if the power to power rule says if I have x to the a raised to the b power, I will then have a times b in that corner parenthesis, because this is like saying I want b a's. I want b of those a's. So if let's say for an example here, this was x cubed to the fourth, that's like saying, hey, I want 4 3-packs. So the power rule goes a little like this. If I have log base b of x raised to the y power, then that's the same thing as the y, bringing that out in the front, of log base b x. Now the reason why that's true is because it's kind of like saying, hey, I want y of these logs here. So if I put them out in front, it's like saying, hey, I want this y quantity of logs. Now the quotient rule, if we remember back to our exponential rules there, if I have x to the a over x to the b, then I would have x to the a minus b. This is an equivalent statement there. And these x's are all, of course, the same bases. So the quotient rule works like this. If I have log base b x over y, then this is log base bx minus log base by. So you can see that side-by-side multiplication of a logarithm is addition. The power of a logarithm is moving that to the front, so I would want y of those. And the quotient, or division, will end up as subtraction. So for the next 6 problems, we're going to do some combining to write this as a single logarithm with a leading coefficient of 1. And then for the last 4 problems, we're going to expand these single logarithms into multiple logarithms. And this is going to be helpful for when we do some solving for x. So let us look at these manipulations here. So what I have to do is express this as a single logarithm. So this one's pretty much already a single logarithm, but I need a coefficient of 1. And the coefficient is that the number in front of the first log needs to be a 1. So using the property called the power rule of logarithms, I'm going to move that -3 over to the top of that x right there. So it's going to be log base 6x, and in the corner, -3. And because I don't like negative exponents, I'm going to make this an x over 1 and flip it on its head. So log base 6, and this is going to be 1 over x, and the whole thing's going to be raised to the 3rd power, so 1 cubed is 1, and x cubed, this would be my answer. Because, again, to slow down and show you what happened, this got flipped on its head, the whole thing was cubed, so that would be 1 cubed and x cubed, which gives you this. Now, in this case, it looks like our leading coefficients are 1, but it's not written as a single logarithm. So since we're in the same base, I would put these together using the product rule. So this would be log base 2 x squared y. It's now together under a single log. The leading coefficient is 1, and these are multiplied together since they were added here. Now what I'm about to do here is turn these these leading coefficients of non-1, I'm going to put those in the corner. So I'm going to have log base 5 x to the 4th power plus log base 5 y to the 2nd power, and I'm going to then combine them because the addition means multiplication in the power rule, or excuse me, the product rule. So this is log base 5, and this is x to the 4th y squared. Now over here, we're going to take a look at this multiple step equation. And to make life a little easier on myself here, I'm going to take these numbers in front and just kind of automatically move them to the corner like so. And now I'm going to combine them under one log. Now I got to be careful here because the first one, not surprisingly, is log base 3x squared. This subtraction means division, so that y to the fourth is going to go downstairs, and this y to the fifth stays upstairs, because plus means multiplication and subtraction means division. If both of these were in parentheses by the subtraction, the y to the fourth and y to the fifth would be both downstairs or in the denominator, but since it was just this right here, that's the only one that's downstairs. Now we do some simplification, leaving you with y in the numerator. So log base 3 x squared, and with 1y in the numerator, that is your answer for that problem. Okay, so what I'm about to do here is combine this inside the parentheses before I move the 1/4. So this is going to be 1/4 log base 2 of xy. And then I'm going to take that 1/4 and move it over to the corner here. So that's going to make it log base 2 and xy to the 1/4 power. And I really want to kind of get used to writing fractional exponents as radicals. So this would be log base 2 of the fourth root of xy under the fourth root there. Alright, so this final problem here, this last one, is going to take probably a little bit of room, so I'm going to kind of move my screen a little bit to give myself a little bit of room. I'm going to use most of this space here. Alright, so there's a couple different ways to do this problem. One neat way to do it is to distribute the -4 so we can get rid of these parentheses here. So this is a little different than the way I did it in class, but what this is going to do, it's going to make our problem a little bit different, but a little bit easier in some ways. So here's log base 3y, and here is positive, and that's going to be a positive 8 log base 3y. Alright, so let's get this started. We are first of all going to move all of these numbers into the corner. So this is going to be log base 3x, and this is going to be a plus log base 3y to the -4th. This is going to be plus log base 3y to the 8th. Alright, so if we combine all of these into one log base 3, we now have an x in the numerator. The y to the -4th is going to go to the denominator, because again the negative exponent flips it to the bottom. And this y to the 8th, that goes into the numerator like so. And we just then need to simplify it. So this is going to be log base 3. 4 on top, 4 on the bottom, or 8 on top, 4 on the bottom, x y to the 4th. So there it is. So that makes kind of a big difference there, doesn't it? And again, it's all because that -4 connected to the y makes it 1 over y to the +4. Alright, so for our final 4 parts of the problem, we're going to take these and we are going to expand them, and we're going to expand them into multiple logs, and we're not necessarily going to go in the order of 1, 2, 3, 4. In fact, I'm going to save this one for last. So let's start off with here and break this into 2 logs. Log base 3 2 plus log base 3x. So that's pretty straightforward, right? I mean, it's just splitting them up because multiplication means addition and division means subtraction. So this is log base 5 x cubed minus log base 5 y to the 4th. And because we have these powers here, we can move these to the front as well. So 3 log base 5x, and then minus 4 log base 5y. Alright, we'll do this last one down here, and then we'll go up and do this one for our final problem of the video. So, I'm actually doing this all in one step. See, all 3 of these are being multiplied, so I have 3 natural logs. I got the natural log of 2, natural log of... Oh, did I write 2? Didn't mean to write 2. I got natural log of x. Boy, that's going to be hard to rewrite there. So natural log of x, natural log of y, natural log of z. And these are all getting added because, you know, they have, you know, basically, you know, multiplication. Multiplication just means addition. But the 2, let's put that in front. The 6, let's put that in front. And the 1, the power of 1, put that in front. So my final answer is 2 natural log x plus 6 natural log y plus 1 natural log z. And we wouldn't write the 1 in front of it. So for our final problem here, we're going to take a look at this. And I think what's important to remember is that the cubic root is the same thing as the 1/3 power. So the cubic root of x is equivalent to writing x to the 1/3 power. So this is going to be log base 6 times r squared z raised to the 1/3 power. Now what I should do is distribute the 1/3 in here. That way I have the r and the z ready to be split, because that's what I'll want to do for our final step. So multiplying 2 to the 1/3, this log base 6 is going to be r to the 2/3, and this z would then be raised to the 1/3. Now what I can do is I can split this up. So now I have log base 6 of r to the 2/3 plus log base 6 r, or sorry, z, excuse me, to the 1/3. Now I just move my fractions in front, so I got 2/3 log base 6r plus 1/3 log base 6z. And voila, I have my final simplified expanded logarithm with the leading coefficients not 1, but with the powers that were in the corners of the problems, and every variable split up. So I hope this helps you in this part of the section, this part of section 2, and I thank you for watching.